No. Oh, I'm on the wrong one. My bad.
Oh, I got framed.
Yeah, I was like, this is gonna be a short lecture today. We're just gonna power through these 47 slides, and
What's up, Slight?
when I get done, so this is better, right?
8 is better.
Yeah, 8 is better than 47. Okay, we're all good with that. So, what we have today is types of reactions, and so literally, you're going to look at an equation and tell me what type of reaction it is. This is not as hard as it seems. Basically, what we want to do is we want to take the equations, like the equations that we were working on last week, and just look at the shape of them and try to figure out what's happening. After we go through the PowerPoint, this will make a little bit more sense. But we have specific names for types of equations, and then you're going to look to see what's happening in that equation and give it a name. So, first, we have a synthesis reaction. If I am synthesizing something, what am I doing? Like where do we hear this term?
Synthetic division.
Synthetic, yeah, well, all right, synthetic reaction, synthetic division. What would I put synthetic in front of? Like, what's another word something that's fake, right? So like a synthetic life form, right? It's like a fake life form. But more importantly, like, what is this synthetic life form?
Dead. No, not real. Alien. No.
Calm down. No. So what would I be saying if I said, oh, this is a synthetic life form, and I pointed at somebody? Maybe like a clone. Yeah, like a clone would work. What else?
Like if I went to a second dimension and I picked myself up from there and came back to my
No, but that's not synthetic. That's just a different you. Like a different you. But like a clone, or what else might be synthetic?
Something made in a lab.
Yeah. So something specifically, something that we make, right? Yeah. So like a dog isn't like a synthetic life form. But if I clone myself, listen. A dog's not a synthetic life form, but if I clone myself, that is. What about like a robot? Yes. Yeah, if it's made in a lab. So synthesizing something means to create it. If I'm synthesizing, let's put it this way. What is a synthesizer?
Something that makes stuff.
Makes what specifically?
Makes robots.
I don't know.
Y'all don't know what synthesizers are? You don't have like music classes?
Music, they make music.
You don't even know what it is. just keep your mouth shut. So look, a synthesizer is an old school term for like a keyboard. And so does anybody have a keyboard at home? What kind of sounds can you make on your keyboard?
Any kind.
I wasn't pointing at you. I was pointing at back there. What kind of sounds can you make on your keyboard? Yeah, but you don't have any of those instruments there with you, right? So the synthesizer is like creating a fake sound of like a trombone or a bass or whatever it happens to be. That's what synthesizing means, to create something new. And so if I'm having a synthesis reaction, what is my reaction probably doing? Creating something new. And so if I look at the way my reaction is set up, if I'm taking two things and putting them together and making something new that didn't exist before, that is a synthesis reaction. So what you're looking for synthesis reactions, it doesn't matter what chemicals you have. If I have two chemicals separated by a plus sign on the left side, and on the right side, I only have one chemical. So I'm taking two separate things, putting them together to make one thing. That is a synthesis reaction because I'm synthesizing something new. Now, the opposite of that is going to be decomposition reaction. What does something do when it decomposes? It breaks down. That's going to be a better one. Erosion's okay, but breaking down is better. So like if something dies and its body decomposes, it's literally breaking down from one thing into a bunch of different parts, right? We're breaking it down into its parts. That's what decomposition is going to be. It's going to be the opposite of synthesis. So in decomposition, I take one thing and I break it apart into its separate individual parts. Does that make sense? So for synthesis, I'm taking two things, putting them together. For decomposition, I'm taking one thing and breaking it apart into its separate parts. Is everybody okay with that? So you can see it doesn't matter what letters they use. It doesn't matter what elements or chemicals they have. I can just look at where the plus sign is, how many chemicals I have at the beginning, how many I have at the end, and I can kind of see that this one, I'm taking two things and putting them together. This one, I'm taking one thing and tearing it apart. Synthesis and decomposition. Now, we got a couple more. We got single replacement, and then we have double replacement. For single replacement, I'm just literally switching out or replacing a single element in my chemicals. So I'm gonna have a chemical that has two elements. I'm gonna have a chemical that's one, and one of these is gonna switch places with the single element. And so you see that here, they have A and X. This is just one chemical, and then I have the B all by itself. And then what's gonna happen when I have my reaction? The B and the A are gonna switch places. Does everybody see how the B and the A switch places here?
Yeah.
I go to AX plus B to BX plus A. The A and the B switch places. That's single replacement. So notice this is a little bit different from decomposition or from synthesis, because on this one I've got two things on both sides. I've got an AX and a B, and then a BX and an A. So I have two separate chemicals on both sides. So it's not a synthesis. It's not a decomposition. I just have one element switching places. That's going to be my single replacement. Now, I can also have double replacement, which I'll show you right here. Double replacement, I got the two pairs also, but nothing's by itself. So notice here, instead of AX plus B, the B is paired up with the Y. So it's not all alone anymore. And when they switch places, the A and B are going to switch places. They both have new partners. And so I'm really switching two different things. They're calling that double replacement. AX plus BY goes to AY plus BX. Everything kind of switches places. And then last one, this one's going to be the hardest to figure out unless you can remember kind of what's going on. So what does combustion mean? If something is combusting, what's happening there? It's exploding, or a better term is burning. So like all of our cars, unless you have like an electric car, all of our cars have combustion engines in it. We take the gasoline and we burn it. And we use the heat from that burning of the gasoline to make energy to push our car down the road. So combustion is literally burning. Now, what do fires need to survive?
Gasoline.
Well, I mean, they're all going to need fuel, but outside of the fuel,
Oxygen.
they need oxygen. And oxygen is the important part. You got to have fuel, you got to have your gasoline, but in your car, if we're talking about cars, you got to have a clean air filter. And you got to have an unobstructed view for air to get into your engine, because gasoline just by itself will not burn. I have to have oxygen to fuel that fire. And if you're like starting a fire in a campfire or at home in your fireplace, you got to make sure you get enough air to the fire so it can burn. That's what I look for in combustion reactions. I'm going to have some sort of chemical. It doesn't really matter what chemical. If I'm combining it with oxygen, and oxygen is really the only thing happening over here, it's going to be combustion. I'm burning something. Oxygen is involved. You can just guess that it's going to be combustion. Another thing that they're not really showing on this side, what happens pretty often with combustion, what comes out of a fire? Heat, and what else?
Thermal energy.
Yeah, thermal energy. What else?
Light.
Light, okay. What else comes out of a fire?
Smoke.
Smoke, all right. Smoke is actually pretty important. What is in smoke? Like
Carbon.
carbon, we're getting closer. But like what happens? Why am I supposed to crawl on the ground and get out of my house if it's on fire outside of like the fire itself?
The fumes?
Yeah, but what am I gonna breathe
I don't know, man.
if I'm breathing in that smoke?
Carbon dioxide?
Carbon dioxide, yeah. CO2 is what comes out of a fire, carbon dioxide. That's what's gonna suffocate me if I don't get down on the ground and try to crawl out. And so one of the things you often see in combustion reactions is CO2. Another thing that you usually see in the chemistry side of combustion reactions, but we don't see with our eyes, is, what is that?
Water.
Does it make sense to you that every time I burn something, normally one of the things to come out of that fire is water? It doesn't make a lot of sense. But yes,
Moisture.
someone had the very important term here. What happens to the water in a fire?
Evaporates.
It evaporates. Like it instantly boils and it evaporates away. And so should we ever see the water in a fire?
No.
No, it's not going to be water that you see just like sitting in the middle of your flames. It instantly boils away and evaporates away. But if I'm looking at my chemistry problems and I see an equation, it doesn't matter what this chemical is. It could be just hydrogen. It could be some sort of big molecule like a hydrocarbon, like gasoline. It could be sugar. You can burn sugar with oxygen, and it will create CO2 and H2O. And so, if you're getting it wrong and you think you got it right, look to see, does it have oxygen as a reactant? And is it producing CO2 and H2O? That means I'm setting something on fire and it's going to be combustion. That's probably going to be the hardest one to spot because you're looking for the other ones. But essentially, that's what we're looking for is one of these different setups to try to figure out what the exact problems are. I'm going to leave this up on the board to help you out a little bit. I didn't tell you to open it up yet. Just hold it down. Hold it down. Let's go over this again. Look. Synthesis, I'm creating something new. So I've got two individual atoms or two individual chemicals. I add them together. I'm creating a new chemical. That's synthesis. Decomposition, I'm breaking it down. I take the one chemical, break it apart into two separate parts. That's decomposition. Single replacement, I'm just switching individual elements, and something's going to be by itself. So I start off single replacement. B is all by itself. I switch it with A. Now A is all by itself. That's single replacement. If I'm doing the same thing, but nothing's by itself, everything's paired up with another element, that's going to be double replacement. So A and B switch places, but they're never alone. They're always next to a Y or an X. And then lastly, combustion. Combustion can look like almost any of these, but it will have oxygen as a reactant. It will have CO2 and H2O as products. That's how you know it's going to be combustion. So go ahead and start on the assignment. I will leave this up. I think literally they're just going to show you equations and ask you what type of reaction it is. If you have any questions or need any help, please let me know. I will be around to help you out.